Hey guys, welcome back to my channel where we explore interesting math problems. Today's video is part 2 of my walkthrough of a contest from the 2022 to 2023 ASMA Senior Division. In this video, we will only go through questions 5 to 7, so if you're interested in seeing the previous questions, feel free to check that out in my channel. And without further ado, let's get started. So question 5 reads, the average of x, y, and z is 10. The average of x and y is 9. The average of x and z is 8. Find the average of y and z. First, let's turn all these statements into equations. So we know that the average of x, y, and z is 10. We know that the average of x and y is 9. And we know the average of x and z is 8. We want to find the average of y and z. Let's call that A. So now that we have all these statements translated to equations, you might have noticed how they all have fractions on the left side of the equation, so let's just quickly simplify all of them to make them easier to deal with. We multiply by 3 here to get this, and the rest are all multiplications by 2. Okay, so now we can do a bit of equation manipulation to find what y and z is, since we're trying to find the value of A. Notice how both these equations have x, and that one has a y and the other has a z. So let's see what happens if we try and add them up. The result is this equation here. And this is very promising because you can see that this equation is almost the exact same as this one here, except it has an extra x. So we can subtract this equation here with this and get that x is equal to 4, which we can substitute back into the equation here. Then simplify to get this. And because we want to find A, we use this equation to substitute y plus z with 2a, then simplify to get that A is equal to 13. And that is the average of y and z. On to question 6. Find the numerical value of the product. And we have this extremely long algebraic expression that I won't read out loud. So we're given this lengthy multiplication. This is very hard to solve when they all have this 1 attached in front. So let's go ahead and add the 1 to the fraction to make it simpler. Like this. Okay, so now we see a pattern emerging. At the numerator, it's a series of consecutive numbers starting from 7, 8, 9, and so on until 25. And at the denominator, it's also a series of consecutive numbers, but starting from 4, 5, 6, and so on until 22. Let's rewrite this into a single fraction. And we now have this. So you might have noticed that I've taken the liberty to expand this part out a bit more, but it's just to make the cancellation easier to see. Because now that we have all this multiplication expanded out, we can start canceling numbers, because we have multiplication at the top and at the bottom. Starting with the 7s, the 8s, the 9s, and all the numbers in between, which we know are the same due to the pattern of consecutive numbers. Then the 21s, and lastly the 22s. So after all this canceling, we're just left with these numbers, which simplifies to 115. And that's the answer to this lengthy expression that we're first given. Lastly, question 7. 3 times the length of a rectangle added to twice its width results in a total of 96. Find the maximum number of square units in the area of this rectangle. Let's first define some variables. Since we're dealing with the rectangle's length and width, let the length of the rectangle be L, and let the width of the rectangle be W. Now we can translate this statement into an equation. 3 times the length added to twice its width results in a total of 96. And also, since the question is asking for the maximum area, let's just write down the equation of the area on the side, which is just simply L times W. Now, how can we use this given equation to help us find the maximum area? A good place to start is to find L in terms of W so we only need to deal with a single variable here. So we move 2w to the right side of the equation and divide by 3 to isolate L, and we plug that in here for what L is equal to, and expand out to get this quadratic equation. So to find the maximum area, we need to turn this quadratic equation, which is in standard form, into what is known as the vertex form, which allows you to know the minimum point of an upward-facing parabola, or in our case, the maximum point of a downward-facing parabola. And the reason why we know that we have a downward-facing parabola is because of this negative coefficient in front of the w squared here. So to get it in vertex form, we need to do something called completing the square. As I won't explain too much of this process, if you're interested in learning more about the vertex form or completing the square, feel free to check out the links in the description below. So first, to complete the square, we pull out the leading coefficient, which is negative 2/3 here, and then add this 24 squared so we can turn this part into a square. But because we're adding things here, we also need to subtract it outside of the parentheses to make sure that the expression hasn't changed value. And then we simplify to get it in vertex form, with this constant out here being the maximum value of that downward-facing parabola that we're looking for. So there we have it. The maximum number of square units in the area of this rectangle is 384 units squared. And that concludes question 5 through 7 of this ASMA contest. I hope you enjoyed this quick run-through of a wide range of math topics, and I'll see you next time for more.